Thank you, Madam Chair. I feel honored by the invitation to participate with a panel of witnesses for this important study of small modular reactors. I serve as the Executive Director of the Sylvia Fedoruk Canadian Centre for Nuclear Innovation. We are a not-for-profit corporation with a single institutional member, which is the University of Saskatchewan, but we have a fully independent board of directors. The Fedoruk Centre is funded through an agreement with Innovation Saskatchewan, an agency of the province, plus revenue from third parties for goods and services that we provide. The purpose of the Fedoruk Centre is to help place Saskatchewan among global leaders of nuclear research, development, and training through 4 key activities. For one, we fund research projects led by Saskatchewan scientists in some kind of nuclear topic of their choice. We partner, secondly, with Saskatchewan institutions to help them establish new faculty leaders of nuclear subjects in line with their strategic plans. Thirdly, we operate a nuclear facility, the Saskatchewan Centre for Cyclotron Sciences. This is a resource for innovation in nuclear imaging for health and food security. And fourthly, we establish consultative resources for the public and policymakers. We facilitate partnerships and develop business related to nuclear innovation. Pretty well everything you do that's got something with nuclear, it's our job to try and help Saskatchewan engage with these things. At this time, the province of Saskatchewan is moving forward with Alberta, Ontario, and New Brunswick towards deploying small modular reactors to help achieve Canada's objective of a cleaner energy future and stimulate a wide range of economic activities and social benefits arising from this innovative technology. It seems very likely that Saskatchewan will place our first nuclear power plant onto the electricity grid in the mid-2030s. Then we will proceed in steps to replace the burning of fossil fuels with a new foundation of baseload electricity to which other clean energy technologies can add. It is also reasonable to consider very small nuclear reactors to power resource extraction industries that are located far from the grid and would otherwise need to be burning fossil fuels to have the energy to operate. Deploying a nuclear power technology in Saskatchewan would not only help to move Canada towards reducing the burden of greenhouse gases on our planet, but can also create opportunities for research and innovation in the surrounding fields, the topics connected to the power generation. Examples would be adding value to the uranium that is mined in Saskatchewan. Perhaps we could be enriching the uranium and fabricating enriched fuels. Both of these economic activities are only performed outside Canada at this time. So there's an opportunity to create new value if we put our minds to it. Another possibility is to manufacture nuclear quality components in Saskatchewan. This would enable Saskatchewan companies to contribute to the Canadian supply chain for building SMRs. Or perhaps we could be a part of responsible management of used fuel as a part of protecting the environment. Saskatchewan will need people to serve as operators, technicians, designers, builders, regulators, safety engineers, control system architects, and security experts. That means we will be needing to create many new jobs in Saskatchewan and fill them with people at all levels of educational development. And that means we need to get started right away, establishing a new capacity for leadership in research and education in nuclear topics at Saskatchewan post-secondary institutions. There's only 3 main ones here: the University of Saskatchewan, the University of Regina, and Saskatchewan Polytechnic. Now is the time to attract new leaders who can create educational programs and establish themselves as trusted knowledge keepers to whom the public can turn for unbiased advice on nuclear topics,